question. This is actually referred to, or it is with respect to kinetic friction, and the object has resultant force. It's not in equilibrium. Let's see. Um, so you can connect to all this. When it's not in equilibrium, it is Newton's second law. And when it comes to second law, when it is acceleration, we should immediately think about F net, mass times acceleration, and so on, right? So that'll be a hint to you. So there is a net force acting on the object, and you need to connect it with the acceleration. Now let's look into the question. A rope pulls a 63 kg water skier up. So 63 kg. So mass is 63 kg up at 14 degrees. I've already drawn here. So it is at 14 degrees to the horizontal. The tension force, so that is the pulling force here, or the applied force that is pulling the skier up with 512 Newton. So we have the tension 512 up. Now the coefficient of kinetic friction between the skier and the ramp. So this is mu k, right? Coefficient of kinetic friction 0.27. Now these are all the information that we have, and the question is, what are the magnitude and the direction of the skier's acceleration? Now here, how do we find F net? We know the forward force, so you need to find out what are the opposing force, or the forces that is acting in the opposite directions, right? Now since here weight is acting down, so you will have a component of weight that is acting in this direction, right? The weights, so that will be in the opposite direction to the direction of the tension. So that will be one of the forces acting. Another force will be, they've already given you the kinetic friction coefficient here, so there will be Fk as well. So these two forces, kinetic friction plus the component of the weight that is acting along or in the opposite direction to the tension, will be opposing forces, right? So if you find this and take the difference, you will get F net. All right, so read the question. When you read, it might be a little confusing, but take it slowly, read it, absorb it, try to sketch a diagram, then you will be able to crack the question. All right, now let's find out one by one. First will find out Wx. So for Wx, if you use your math skills, you will get this angle to be 14 degrees. So we all know the line that is touching the component this will be cos and this will be sine. So we are not interested in this cos component for this particular question. So I need to find the x component, which is W times sine 14 degrees. Right? Now, have they given you W directly? No. You have the mass. So you can, from here, you can find W by using formula m times g. So it is 63 times 9.8. Right? So I put that all in here. 63 times 9.8 times sine 14 degrees. I will get the component. One of the opposing forces I will get. That would be 63 times 9.8 times sine 14. You get 149.4. All right. So one opposing force I found. Now I need to find Fk. That is the frictional force which will be opposing the movement. That would be, if I use the formula, mu k times Fn. Fn is otherwise force of gravity, or again W, which would be, so mu k is 0.27 times 63 times 9.8. This is your Fn, okay? The normal force, which will be equal to the weight. So you get here 0.27 times 63 times 9.8. You get 166.7. So these two together will give me the opposing force. So when you add them up, you get 316 approximately. So 316 Newton is the opposing force. So I've calculated both the opposing forces. Now I need to find the F net. F net equals the applied force, the forward force, minus the opposing force, 512 minus 316. That gives you 196. Okay, so F net is 196, but the question asks for acceleration. Acceleration used in this formula. So acceleration equals F net over mass, that is 196 upon 63. You get around 3.1 or 3.2. Okay, since I've rounded off, you should get approximately 3.2 meters per second square. All right, it might look confusing, but actually if you break it down into steps, follow it one by one, you'll be here. As I said, we are applying two things. One, Newton's second law. So you're finding out all the forces acting on the object by using the formula. Break it down into components for W, and for FKU's formula you get two forces. Add them up, you get the total opposing force, which is 316 Newton. All right, then take the difference, that gives you F net here. Then from F net you find acceleration by substituting the formula. I hope you got it. I know this is a little tricky one, but practice such kind of questions so that it will be easy while you're solving questions during the exam. All the best.